So today in college algebra, we're going to start looking at period changes. Okay, we're eventually going to get to all the changes at once, but today we're going to focus on how the period will change and what to do with it. Okay, so first of all, the period is the time it takes to complete one cycle. Okay, so if you remember from the notes on Monday, Tuesday, this is for a normal sine and cosine graph, 2 pi. Okay, so once around the unit circle. But there are equations where the period was going to change. You can see that here. So for the equations in the form of y equals cosine of bx and y equals sine of bx, the period will change. So if something's being either multiplied or in some cases divided with the x term, the period will change in your graph. Okay, so it's going to change from 2 pi to something else. Okay, to find that new period, you're going to take whatever is being multiplied by the x term or divided and set it equal to 2 pi and then solve for x. Okay, so let's see how this works. So we have here 4x. So we're going to take 4x and set it equal to 2 pi, our normal period for a cosine graph. So we're going to divide both sides of this by 4. Then we're going to reduce, and x will equal pi over 2. So our new period for this particular graph is going to be pi over 2. So what does that mean? That means from the start to the finish, you're only going to traverse over pi over 2. So it's going to basically compress the graph horizontally to shrink it. Okay? But we're going to not really show you that per se in terms of, it's going to be hard to show you that because the points become too crazy and compressed. So what we're going to do instead is show you that through our intervals. So if the graph period is now pi over 2, we're going to end up at the end here at pi over 2. Okay, so now I kind of mentioned how I would show you a trick for period changes later on. Well, this is that time. So this is how the trick works. You start at the end with the new period, which is pi over 2. What's half of pi over 2? You're thinking, I don't know. Basically what you're doing is you're going to multiply the denominator of your fraction by 2. So 2 times 2 is pi over 4. That's half of pi over 2. Now we want to know what's half of that for the first term. Well, again, multiply your denominator by 2. Gives you pi over 8. The last term that we haven't figured out is that third line in there. So what we're going to do is multiply the first period interval by 3, which gives you 3 pi over 8. You now have your period intervals written down for your graph. Okay, so it's half, half, and multiply by 3. That's the sequence you write down your intervals in. Okay, now we can start plotting the points for our graph. So it's a cosine graph, and the amplitude is, because there is no term there, no coefficient there, it's a 1. So cosine graph starts at 1, goes down to 0, down to -1, up to 0, and up to 1. So our graph will look like this. Nice gentle sweeping curve. And there you go. Now if you want to put your intervals down at the bottom, that's fine too. It just, wherever you feel more comfortable doing it. Okay, let's look at number 2. Again, we have something that's being, in this case, divided by x, or dividing x rather. So we're going to set that x over 2 equal to 2 pi, which is a normal period for our sine graph. And to get x by itself, we're going to multiply by 2. So x will equal 4 pi. So now our graph is going to be stretched horizontally. It's much wider than it usually is. And the ending point is going to be 4 pi. I'm going to put the intervals down at the bottom to make it clear so they don't get involved with the points of our graph. So the same thing applies for the last interval changes that we did. Okay, what's half of 4? Well, half of 4 is 2. What's half of 2? 1 pi. And 3 times 1 is 3 pi. So those are our intervals for the graph. Now, where you put your intervals for your x-axis is up to you. Whichever one you like to do. You can do it inside, right underneath the x-axis. You can do it at the bottom of the graph. It's really up to you. Now we look at our graph, okay, and plot our points. So the coefficient in front of the sine is still 1, which means sine starts at 0 goes up to 1, goes back down to 0, down to -1, and back up to 0. And then we can plot our line. Okay, again, this is just one period of our graph. We're looking at one snapshot of once around the unit circle. Now that intervals will change because our number inside the parentheses on the x changed, but we're still looking at one snapshot. These graphs will continue in both directions over and over and over again, doing the same thing. All right, look at the next one. This one has a period and an amplitude change. Now they don't really affect each other, so one doesn't have an effect on the other one. So we can look at the period change first. So we have 3x equals 2 pi. We're going to divide both sides by 3 to get x by itself. So x will equal 2 at pi over 3. Okay, somebody's like, oh no, this is going to be hard to figure out. It's really not. Okay, if you follow the directions. So you have 2 pi over 3. I'm going to put the intervals at the bottom of the graph again. So what's half of 2 pi over 3? Well, again, multiply the denominator by 6. Or sorry, by 2, which gets you 6. Okay, but for this case, because you're going to get 2 divided by 6, that's a reducible fraction. You have to reduce it. 2 over 6 is 1/3. Okay, so again, divide that by 2, or multiply the denominator by 2, which is going to give you pi over 6. Now multiply that first one by 3, which gives you 3 pi over 6, which can again be reduced to be pi over 2. Okay, so you might have to reduce some fractions, but it's simple fractions. You should be able to do that in your head without a calculator. All right, so now we go back to our graph and our equation. So we have our intervals down. Our amplitude is 4. Well, a cosine graph usually begins at 1, but we're multiplying that by 4. So we start up at 4. Then the amplitude is go down by 4, down by 4 again, up by 4, and up by 4. You can, by now you should have seen there's a pattern between cosine and sine graphs. And there we go. Number 4. We have 1/4 over x. This can be rewritten as x over 4. It's the same thing. Equals 2 pi. Multiply by 4 on both sides. And x will equal 8 pi. So that's our ending point for our period. Oh, there we go. I want to take 8 pi and divide it by 2, which gives me 4 pi. Divided by 2 again, gives me 2 pi. Multiply 2 by 3 gives me 6 pi. I do this every single time for my period changes. All right, now we look at our equation with the amplitude. The amplitude is 2. Remember, amplitudes are always positive, but it's got a negative sign in front of it, which means it's reflected over the x-axis. So sine generally begins at, well, not generally, sine always begins at 0. We multiply it by 2. Still get 0. Now because it's negative, instead of going up first, it goes down first. And because it goes down, it's going to be going down with an amplitude of 2. So we go down 2. We go back up, and go back down by 2 each time. Connect my points, and there's my sine graph. Okay. All right, got a couple more. So we got 6x equals 2 pi. Got to find the period change first. Divide both sides by 6. X will equal, reducing that fraction, pi over 3. I'm a little short on space at the bottom of this graph, so I'm going to put my intervals in the middle of the graph. It's okay, either way works. So I have pi over 3 as my total period for this particular graph. Half of pi over 3, you multiply the denominator by 2, gives you pi over 6. Half of pi over 6, multiply the denominator by 2, is pi over 12. Multiply that, pi over 12 by 3. 3 pi over 12 is pi over 4, because I reduced 3 over 12. All right. Cosine begins at 1, but we're multiplying it by 3, and it's being flipped upside down, so it's going to start at -3. The amplitude is 3, so instead of going down 3, down 3, up 3, up 3, I'm going to go up 3, down 3, and down 3 because the graph has a negative in front of it on the amplitude. Again, the amplitude is not negative, but there's a negative in front of the amplitude. And there's my graph for negative 3 cosine of 6x. One more example. X over 3, set it equal to 2 pi. Multiply both sides by 3, and we'll get 6 pi equals x. Let's do that. Let's do it right. So again, I'm a little short on space at the bottom. I'm going to put it right in the middle. So I have 6 pi. Well, half of 6 is 3 pi. Half of 3, since the denominator is 1, I can put 3 pi over 2. Because I'm dividing 3 by 2. And since you can't reduce it, just leave it like that. Multiply that number by 3, which gives you 9 over 2. So there's my interval. I'm doing a sine graph. Sine generally begins, not generally, sine always begins at 0. All right. The 4 on the amplitude means I'm going to, from 0, I'm going to go up by 4, down by 4, down by 4, and up by 4. And there's my sine graph. Okay. Please try the practice. Okay. A lot of times, this is not that hard, but a lot of times students will just forgo the practice and they'll get lost on graphing these. These are pretty simple to do. There's not a lot to do them because once you do enough, you get the idea of the pattern for sine and cosine, and then it becomes much easier. So make sure you practice and come to class next time with questions. All right, good luck.